Hi, I'm Doug Turner. Welcome to Building Paradise. Our episode today is about pouring the concrete foundation on a custom home in the 30A area. And we have as our guest Blake Becknell from Anderson Engineering. Well, Blake, thanks for joining us today.
Absolutely.
Appreciate you coming out. It's a beautiful day. We thought we were going to have some rain, and we're going to be able to pour probably all 6 trucks plus, or maybe more than 6 trucks today. So we're out here at 152 Needlecast Lane, Watersound Origins, and it's one of the hottest markets in the 30A area. And this home is going to be approximately about 4,000 square feet when it's finished. It's going to have a great pool, cabana. It's going to be an awesome house. But right now we're focused on pouring the foundation, and Blake is here today to share with us the process of designing the structural foundation and making sure it gets built right. And Blake's with Anderson Engineering. And Blake, tell us a little bit about Anderson Engineering, who you are, what you do, what's in your wheelhouse, and what kind of work y'all like to do.
So Anderson Engineering, we've been started since, I believe, 1954 is when we were founded.
Wow.
We've got about 160 to 170 employees company-wide. So we've been growing crazy amount in these past few years. We've actually opened, I think, 5 offices in the past 2 years. So,
what locations are you operating out of primarily?
So our headquarters is actually in Springfield, Missouri. So we have a lot across the Midwest. We have 6 offices across Missouri. We have 1 office in Rogers, Arkansas. And then we have the Destin office here, which is the one I'm based out of. And then we have a Navarre office and a Milton, Florida office.
So you're covering the area?
Yeah, and we're trying to grow too. We're moving into the Panama City market, the Pensacola market. So yeah, it's
okay. So when kind of explain what you do as far as after the architect finishes the plans, we contact the structural engineer, and because we live in this area that has a lot of storms, hurricanes, we have to build to, I think it's the 150 mile-an-hour rating. So how do you guys design the plans, and what we need to be looking for on a structural set of plans?
So on
a house like this in particular.
Such as this house, we, like you said, the architect will send us the plans for a custom home. So we have to, first we pretty much just take the architectural plans, strip them down to what we need, the walls, mainly the bearing walls, exterior walls. And then from there we run an analysis on the entire structure, especially with the, like you said, wind loads in these areas. Most of Walton County falls in the 140 mile-an-hour wind zone. So we take those, we design, we figure out our loading. We start with the roof framing, design that, and we go down per floor, track it all the way down to the foundation. And as we're creating plans, we're running numbers and designs, and then we give you the finished product. So the main thing you want to look for on the structural drawings is the hold downs, the reinforcing in the foundations, the framing members, beam sizes, connections, things like that.
So when we're tying the house from the footing, from the steel in the footing all the way to the top plate, in the end there's a connection, right?
Correct.
So now we're looking at a different point of the foundation. As you can see, we're getting poured out. There's a lot of activity going on, but there's a lot of work that takes place before we get to this point. This is the end of the process for the foundation pour. It's the slab pour. And after that, we're ready to start going vertical. But let's talk about for a minute all that has to be done before you start construction on the house. The first thing we've got to do is we've got to clear the site and get all our temporary power poles connected, and water meter and standpipe, so we have water for these guys to work with, and put up all your signs. And so once we get all that done, we bring the surveyors out, and they're going to pin the building corners so we'll know where exactly it's supposed to go, just as Blake and his team have put it together on the civil plan. And so it all matches, because we're working from the building permit set, and now we're going to execute those plans. So once the surveyor's through, then the concrete finisher comes out and he lays out the house, what's called a batterboard system. Those are all gone now, but that's your string lines for all your exterior walls. So we set all that up, and then they begin to dig. And they dig the footing based on the structural plans, and we're going to show you some examples of that, of how the foundation page is. And we dig it according to the foundation page that Blake has designed. And once it's dug, then we bring our geotech engineer out, and we're going to test for compaction of the bearing capacity of the footing. And Blake, can you comment on why that's important?
Sure. Yeah, that's very important, you know, to figure out. First of all, so by Florida code, we're allowed to design between 1,500 and 2,000, depending on, and that's 1,500 to 2,000 PSF bearing capacity. That's the carrying weight of the soil, or the carrying capacity of the soil. So we're allowed to design to that by code, but without actually doing a compaction test, you know, there's no way to really know that you're actually going to get to that capacity. And if your soil's loose and you're not compacting it properly, then you're going to have some serious initial settlement, and that could cause all kind of cracks, drywall, slab cracks. It could cause the structural issues. It could also cause many aesthetic issues, which you see quite often, unfortunately. A lot of people don't get compacted, and then you have that initial settlement, and it's kind of just always going to be a problem.
Yeah, compaction is something that's important. I'm not sure if it's required. I'm told by the finishers, several builders don't go through that process, but it's just something we do because we feel like it's important to start with the right compaction from the very beginning, because that's where your foundation is built on. So that's important. So once we've done that, then they'll place the steel, and Blake, you'll come out and make the foundation inspections.
That's correct.
Once all the steel is tied. And tell me what you're looking for when you're doing a footing inspection.
Yeah, so we have a couple inspectors on our payroll, and I do inspections sometimes myself, and so we come out, we take a look at the number of reinforcing bars that you have, the depth of your footing, because that's important. A lot of times, people just dig 12 inches down from grade, and your footing's doesn't have any cover over it, which can be an issue. So we check that. We also check the number of vertical reinforcing bars, which you can see all the vertical bars that are hooked into the slab. Those are actually tied in place into the continuous foundation reinforcing, and those are poured in place prior, because a lot of people try to wet stick them, but that'll cause air bubbles in your foundation, and it's just not a good design. So we check all that when we come out and make sure it's all good to go, and then we give you the okay to pour.
So once we've got that okay, we do the same thing. We bring the pump out here like you see here today, and we pour all the footings, and then we deliver the block materials, which is going to be all your block. You have regular block, open bottom lintel block, your duo wall, your sand, and your mortar. And the finisher, the same people who are out here now, they do the footings, they install all the block work, and we bring it up to the grade as it's been proposed to on the civil plan to show what the finished floor elevation is going to be. And that's kind of what you see here now. So about this height is what's required by the neighborhood for proper drainage and so forth. So we get the block in, and then we're going to backfill it with clean fill. And once again, we're going to bring the soil scientists out again, and we're going to compact this soil in approximately 1 foot or so lifts as we fill the slab to make sure it's compacted to the requirements, approximately 95% to pass. And you can see those. We're going to attach some of those documents so you can see what those look like. And then once that's done, the next step is now you've got compacted fill and nothing else, and we bring the soil treatment termite people out, and they spray the slab for termites. Most builders are getting away from doing that, and they're just relying on the Centricon system. And that's really another show that we're going to do about soil treatment, but we feel like we should treat it too, because it's got protection while it's got it under construction. We do bring Centricon out at the end of final grade and put the baiting stations out. But that's really another episode. So once all that's done, then we begin the mechanical underslab process. We bring the plumbers in, and they run all the pipes that you see here, and the electricians, anything they have to do under slab to run. You may see a a line that goes to an island bar or some floor plug receptacles in a living room so you can float your furniture. So we think about those things so they're there when you move in the house, and it's easy to plug all your lamps in. So all that is done. And also early, just to backtrack a little bit, in the beginning, the electrician comes out and he puts a grounding rod that's connected to the rebar that ties into the house that he'll eventually connect to when he powers the house. So all those things have to be done. You know, you look at a foundation, you say, well, so what? But there's a lot of things that have to go into place, because a great foundation will make a great house. And that's what we try to do. And after the mechanical people are through, then the finishers come back out. And once again, they're going through Blake's plans again on the structural plans, and they're looking for, you know, weight-bearing footers that have to be put in the foundation for weight-bearing walls above. And they're going to put more steel in. And then they come out, once that's all done, then Blake and the county, y'all come out and inspect again. So what are you looking for prior to the pour?
So on the slab reinforcing, you know, this slab specifically, you had a lot of interior bearing walls, the way the load path tracked through the house. So we have to make sure that those interior thickened slab, which is basically a footing that's at grade level, we have to make sure that, you know, those are in place, because those are crucial under a load bearing wall. And then we also check that all your welded wire mesh is in properly, which is the slab reinforcing. It, you know, it helps meet that minimum area steel, as well as helps with cracking in the slab. And then, as Doug's mentioned a couple of times, these bars that tie into the slab, those just make for the you know, the proper connection between the stem wall foundation and the slab itself. Yeah. And as you get taller with your slab, those become more and more crucial, because it, you know, allows that wall to tie back into the slab itself.
Yeah. And also, you know, during that process, and just kind of backing up a little bit, where those rods, those bars have been turned down flat, well, for a long time they're vertical throughout the process. And you'll see these orange rebar caps that we use, and that's something we do for safety. It's not really utilized that much in the industry, but we want to take care of our finishers and our people working around the foundation. You know, other things we do is, you'll see this site is completely fenced with construction fencing. We do that, and we want to make sure we're taking care of our neighbors and any natural areas behind or lakes. So when the wind picks up, we can contain the trash and get it cleaned up. So it's just kind of a good neighbor thing to do, and we do that on every one of our sites. So now they're out here pouring, and we talked about the anchor bolts. So I've got 2 anchor bolts here, and this one is the standard. What do you call this one, Blake?
It's a J bolt, or yeah, just typical old J bolt or L bolt.
And so now let's talk about this bolt. Where do we use, tell me what this is. We're starting to use these now for more structural integrity versus this bolt for the threaded rods. And tell me the advantages of, and tell the audience what this bolt is right here.
Yeah, so this specific bolt here, this is a pre-engineered, you know, bolt that's actually engineered by Simpson. It's a SSTB. They have load tables on what these can take, and you know, they're extremely strong. I mean, much stronger than these. These have see how they could straighten out pretty easily under a heavy load. Those can straighten out, and they've actually been tested to.
Where this part here, when you say straighten out, this part here just
correct.
Just
bends, basically just bends out,
and then the roof just goes off.
Yeah, exactly. So these are designed to have much higher tensile strength with this you know, profile that they have here. And if you look at it, it also offsets to the inside at an angle.
See the angle there?
So this allows you to have much more concrete cover on, you know, the structural portion of this bolt. And that, you'll see a lot of time if you go around many houses, the side of the block will actually blow out once these get under some load, because they don't have enough edge distance from the side of that block, and they end up blowing out. And that's why Simpson manufactured these, to kind of offset in a little bit.
Yeah, and the cost between this one and this one's probably 8-10 times more than this regular J bolt.
It is.
So you got more of an investment. It's more cost, but you're getting what you pay for.
Yep.
You're getting much more strength.
Much better product. And in some applications, you know, these are fine. But you know, in this high wind area, Doug's actually gone above and beyond. We didn't actually specify this on this specific house, but he knows it's a great product, and
I think at the end this was the easiest way to accomplish what was required.
Yep.
And that's why we've ultimately went for that.
Yep.
Simpson's makes great product. They take care of all these tie downs. One of these houses right here has about $4,000 worth of metal after the foundation is poured, not including what's in the foundation, after to tie everything in. And that's another episode, but there's a lot of metal in these houses. So now, over the next few hours, we'll finish pouring out the slab, and they'll begin the finishing process, and they'll be putting these anchor bolts down as prescribed. Towards the end, probably tomorrow, they'll come back and cut in what's called control joints. And so, Blake, tell me why we need control joints.
Yeah, control joints are they're another measure of crack protection. It basically guides the cracking in your concrete, because as we all know, concrete it's a brittle material. It's going to crack. When concrete cracks, you don't want to have cracks running through your garage, which unfortunately a lot of houses do. It's pretty common to see. But if you cut the control joints and then fill them, that'll guide the cracks, so making them invisible. So,
yeah. I have an old friend that had a concrete company in another city I was building in many years ago, and one day we had the same conversation about concrete, and he said, "Doug, let me tell you, there's two kinds of concrete. There's concrete that's cracked, and there's concrete that's going to crack."
Yeah, that's right.
And that was, kind of that word of wisdom. And so that's why we know it's going to crack, and that's why we put in the control joint.
Yep.
So, and that's, after that, that's it, and we're ready to go vertical. So I hope this was informative for you. And it's kind of dry, Structural engineering is a dry topic, but it's critically important. And that's why I wanted to share it with you. And Blake, I just want to say thanks for coming out today.
Absolutely.
And joining us and being our guest. And look forward to seeing you out on the job again, man.
Thanks for having me.